right? With that being said, let's take a look at these questions. FJ owns seven dairy cows, 1, 2, 3, 4, 5, 7. He milks them every day and keeps detailed records uh, the amount of milk provided by each cow during each milking session. Not surprisingly, FJ highly prizes cows that provide large amounts of milk, pretty much contact stuff. And the cows, being lazy creatures, don't necessarily want to be responsible for producing too much milk. If it were up to them, they would each be perfectly content to be the lowest producing cow in the entire herd. Basically, they don't want to work hard. However, they keep hearing FJ mentioning the phrase farm to table with his human friends. And while they don't quite understand what this means, and they have a suspicion that it actually may not be the best idea to be the cow producing the least amount of milk. So they don't want to work hard, but neither of them want to be the last one to produce the least amount of milk. Instead, they figure it's safer to be in the position of producing the second smallest amount of milk in the herd. So please help the cows figure out which of them currently occupies this desirable position, right? So this is, well, description I think is very clear. So 7 cows and trying to figure out who is the second to the least, second to the least one, second to the one who provides the least amount of milk. As to input, you see here, you're going to have N stands for what? The number of entries, the FJs in the milking lot. So the N, the number is less than 100. That's why this is bronze level question. Each of the N following lines contains the names of cow and one of the 7 above, so 1 to 7, and followed by a positive integer at most 100, indicating the amount of milk produced by the cow during one of its milking sessions. And any cow that does not appear in the log at all is assumed to have produced no milk, which is 0. All right. And you are supposed to output what? Just output a single output. Please print the name of the cow that produced the second smallest amount of milk. And there's a certain restriction here to handle the corner cases. If, let's say, M is the minimum total amount of milk produced by any cow, so you need output the name of the cow whose total production is minimum among all cows that produce more than M units milk. What if you have several cows producing the same amount of milk who's the second to the least? So here it is. If several cows T for this situation, or if no cow has this situation, so basically everybody produce, 0, for example, and please also output the word T or tie. Don't forget to add a new line. Don't forget to add a new line character at the end of the line of output. So you're gonna system print line. So after that, so note that M equals 0 if one of the 7 cows is completely absent from the log. So which is, we assume, she produced 0 unit milk. All right, so simple enough. So look at the sample output. So you're gonna have a 10 logs, and each log contains the name and also the output. And of course, you will see several logs, for the same cow, such as LC 3 units and then LC 4 units. So LC gonna have 7 units up to now. So in this above examples, if you calculate in a BC, LC, and a DSC all tie for a minimum by 7 units milk, the next largest production, if you calculate, there's going to be the other folks. So that's for 9 units. Question is very simple, to be honest, but I want to talk this question to expand a little bit. I guess today we have bronze people and also silver people, so perfect. Let's talk about the data structure for bronze level to handle these questions and also silver level to handle these questions. Assume this N is a very big number, all right? So 100, of course, brute force, whatever way you can resolve it is. All right, now people understand the question. So let's go to our go to our coding pad here. So this example, look at this example. The idea is basically we need to creating a pair, right? The pair would be the cow, which cow, or just cow name, and the other is output, isn't it? So forget about whatever data structure pops in your mind. What we need a pair. We need to associate the cow with the total milk output at the end. So you're gonna have a list of pairs, and you have to traverse it to find who is the second to the least one. That's it. That's this question. No surprise, right? So with that, you got to think about really brute force. I mean, this brute force, you can actually literally, what is brute force? What you're gonna do? What you're gonna do is you're gonna create a pair of literally this one for each cow, right? And maintain and track it and track along the how many logs, right? Log sessions. And while you track along the sessions, you're gonna maintain basically the second element, second attributes of the milk output. And after that, you're gonna what? You're gonna rank it, right? Rank it up. Rank to find the second to least cow. So find the cow who produced the second to least amount of milk, isn't it? Right? So without any data structure, you can actually build a data structure such as class pair, right? And we're not necessarily to show everything here, but just open your idea, right? So you're gonna have attributes such as the string cow, and then what? And then what is output, and also constructor, whatever, right? So with that, you can think about you're gonna have a list of pair, and with that you're gonna maintain all the 7 cows. So this algorithm is gonna be like that. So you're gonna for each log, and for each log, what you're gonna do is find the pair for that cow, and then what? And then update this, right? Milk output, isn't it? And after that, what is the next one? Next one, you can either sort or rank. If you use the sort, they're gonna be n log n. If you use a rank, that's gonna be O of n, right? Actually, for these questions, it's very interesting. I mean, algorithm is just okay. It's how you're gonna using rank to find the cow who is the second by linear time instead of sorting it, because that's a really waste time. You only care about who's the second one, why you have to sort everybody, right? So look at this, that will work, right? And also for this, for each log, so this one's gonna have a little time, consumption here, because you see here, to find the pairs. In order to find the pairs, you have the pairs with the cow output associations. You have to sequential search to find the pair. So that's why every time you check a new log, that take a linear time. So actually for this step, you're gonna have n square time complexity, isn't it? So if really for this question, n is a very big number, I mean, easily can escalate it to a big number. So this definitely doesn't work. And if only because of that, you can think of whatever data structure you have learned from the session, because that's a driver. It's not you just go ahead and propose, hey, this is a harsh map. And people are going to ask you why. Why you propose harsh map? For whatever reason. And the reason is here. Because I need to find the pair. I want to find the pair by using constant time instead of linear time. That's why you want to get the help from any data structure. So that data structure apparently is going to using the set or map, right? If people can recall set map, there are 3 attributes from that. What is the first one? Deduplication. Because it is a set. Set does not allow duplication. That's why it's a perfect for deduplication. What about the second one? Second one for search. For whatever data structure, you should allow clients to search. But what is the cost? If the average time for set or for map for the keys, searching for the keys is constant time, right? Worst case is kind of linear time, but average case is constant time. So that's a driver why you want to, associate the data structure set or map for these questions. What about the third one? No order, right? For data for map, I mean, the duplication, search, and no order, right? And for now, people should be very solid with it. Okay. And so for this question, you only need to replace this step, and instead of pair, you're gonna have a map, and you're gonna have a key value pair, right? That kind of pair is a pair, but it gotta take constant time to find the key, to find the cow. So why not? So for this map, the key is what? Is a cow's name, right? And what about the value? The value is exactly the new output. That's all about, right? So replace this by using the hash map. And then the next step is definitely want to rank. I would rather show that in the coding instead of just talk about that. Or of course, you can also sort it out. Why not? In log n, the n is just less than 100. Definitely question allowed it. But if n is super big, and you cannot, you got to rank it. In terms of rank it, this is just a general trick, right? For example, you have a lot of numbers, right? So the question asking you, tell me who's the first, who's the second, for largest, second to largest. So we know that this is just doesn't need to sort everybody, right? You sort everybody, you waste the time, you waste the space because you only care the largest. If the question only asking you what is the largest, well, just traverse, right? Traverse and maintain a variable and just update as accordingly. But if the question also asking what is second to largest, it's gonna be the same reasoning. You're gonna maintain a large and in the largest one, and when you traverse with whatever number, you're gonna compare largest one or second to largest one, so as you can update the number as accordingly. So it's kind of like you have a ranking board, and then you have your eye traverse each body. You're going to maintain that ranking board to including the largest one and the second largest one, right? That makes sense. You have to maintain the largest one because for now the largest one could be the second to the largest one for the next round. So that's why, right? Okay. So no surprisingly for this question, after here, that's pretty much for bronze people. You should can handle by using set, harsh map, and by using traversal to rank it. Now for silver people, what about priority queue? To save the time, I will not just kind of matter to introduce you to priority queue. Now you should jump to priority queue. For this question, think about it. What about priority queue to handle this question? The priority queue in terms of that, you can throw the number into that. Because after that, you want to find either smallest or second to smallest, actually for this question, asking that. You can maintain a min heap, right? And after you put everybody into that, and then you can pretty much pop the smallest one. If you have several same smallest one, just pop out. And then the next element who stay on top is going to be the second one. So this is another alternative way to resolve these questions by priority queue, right? This is belong to server, but also in my bronze and the basic server, I guess everybody already be solid with the priority queue and understand the driver. Okay, I think I have a question. I'm thinking it's a second to lead, not a second. Yes, Joshua, but this question is small and it's for smallest, second smallest. But for this, I just showed example, right? So this question is asking for smallest, it's about the same. All right. With that being said, I think it's rather clear. Shall we to code it out? Any questions other than that? All right, seems that we are good. Now let's get to the problem solving part. Now this one is called no last, not last. Okay, let's do that. Okay. All right, so let's creating a class called not last. And let's get this part, get to here, which is to capture input and also output. All right, let's get started here. First, I want to remind you, I didn't really mention that, is what if there's a several cow who does not present in the log, so which means the minimum output gonna be 0, right? So your code should capture that. If the log does not include, 7 cows, which means the minimum gonna be 0. How would you know that? Well, one way is, why don't you also put the cow doesn't show in the log also into your hash map, but just the value is 0. And with that, definitely you can capture the minimum one, it's gonna be 0. So with that being said, why don't you capture all the cows' names here? Right, this one I just copy from the 7 cows. Right, so the 7 cows. And then you want to have a map, and the key is going to be the min, and the value is going to be the output, going to be integer type output. A new hash map. And like that, let's put everybody into your map first of all, and with the output going to be 0. So you want to put each cows into a hash map, and the output gonna put the association with the cow, and the value gonna be 0. Right? And also this meaning is called the end logs, right? Okay. Now pretty much we get what we want, and then we want to maintain your hash map, but all these values. So for this gonna be I gonna go with 1, and I gonna less than n, and I plus plus. So you have an n logs, that's why for loops to get each of them. And you can put a 1 line, but just for demo, why don't we be clear? So the cow gonna be int next, right? And then the output, which is out, is gonna be int next. Right? So pretty much you get a cow, you get it out. This is value pairs. You want to fill into your hash map, but update it if it does exist. If not, just put there. So the key is going to be cow. The value is going to be what? You gotta have the association whatever, right? Because you put everybody already in your hash map. So this one you're gonna have output get cow, and plus this new output in that given log session. And up to here, I'm pretty sure you capture everybody, right? And you have the hash map to record the pairs, all right? And then rank. Right? So rank to find it. The requirement you had to using by linear time instead of n log n. So first of all, you got to think about that is in order to find the second to the smallest, you had to maintain. It's like a board, right? Who's the last one? Who's the second to last one? And what is her name, right? So that's why you want to maintain first of all and initialize 2 variables. So this is the so far minimum. That's the last one output. You're gonna initialize with a number. You want to, so here you can go integer maximum value is fine, but you can also go with 701 because this one said for each log the output maximum is 100. Let's say that all the sessions is what? Is from the same count, all get 100. So which is not the case. So you can put a 7 on 1, or just go ahead with the integer max value is also fine, right? And also, what is her name? So minimum cal, right? So since this initialization, we have no idea. So just now, it's fine. And also, you're going to mention the second one, which will be in second output. Going to be again, right? And also, what is her name? Which is second cal, going to be now. All right. So this is your ranking board. You set it up. And what is next? So next is we want to create a view for the pairs because we want to traverse it. Now the syntax I'm using Java. For C++ people it's going to be similar. So I'm going to show you as Java. You want to have the pair. We know that for the map, it has an entry set. So with that, you're going to have entry. So each entry, which is basically the pair. Now you want to capture that by map entry. Some string and integer, and this is the entry, and this is coming from your output, and this is entry set, right? And now you're going to have a view. So you're going to traverse each pair. Now again, so why don't you record it? So entry get key. So that is this cal, and also the output will be entry get value. So this is going to be the total output for this cal after, n-log sessions. All right. And then you're going to discuss several cases. Case one. What is case one? Case one, let's say for this cal output, which is the minimum. How do you know that? If this output from this cal is less than the record, who's the benchmark? The minimum output, right? If less than minimum output, guess what? Maintain it, right? Maintain it, which means this is the minimum. This benchmark is not this original number anymore. It's gonna be what? It's gonna be out from this entry. But before you update that, you also need to update your second to the minimum, because originally, because your original minimum now becomes the second to the minimum. So you have to update your second minimum first of all, right? So that's gonna be what? It's gonna be second output, gonna be the minimum output, and then what? The second cal, whose the name is gonna be was originally the minimum cal. And after that, you gotta go ahead and update the benchmark. Then the minimum output gonna be the OUT, and also the name of the cal gonna be that cal, right? Gonna be this cal. That makes sense, right? That's the first case. Any other case? Else if, what if you have to update the second minimum one? So which means if this out is less than the second output, right? And also you got to making sure this out is greater than the minimum output. So this will be second case. Case two, which what? Which is second minimum, right? Second minimum output. Well, so go ahead and just update the second one because the benchmark is untouched. So second output is going to be out. And also the name wise going to be what? Going to be that cal, right? And what else? We talk about two situations where we don't see the tie, which the same cal, the same output from multiple cals, but that could happen. We can see the tie happens at the benchmark minimum or second to the minimum. It could happen, right? So we need to capture there. So else if, let's say we see the tie where with the minimum benchmark. So which is going to be case 3. which is tie on the minimum. Think about it. If so, whatever that count, we are never going to be the answer. Let's say later on, this minimum, so this minimum output becomes the second to minimum, which is supposed to be the answer. But the answer should be just tie instead of a cow name, right? Whatever that log move up to, so we can just go ahead and update what? Update the name of that cow to be just tie, because later on when we print it out, the whatever minimum, second to minimum cows, the answer it should be tie, right? Or what? When the output gonna tie with the second, it's possible, right? That's case 4. So tie on the second to minimum output. Again, that cow, that second cow's name is gonna be tie. So, and change second cow gonna be tie. Is there any other case we didn't include in here? And let's review, making sure there's no bugs. And first of all, we've got new benchmark, which is minimum, because we had to making sure this out from this pair is less than the benchmark. Only with that, we have to update it. Before we update it, you're going to update the second one. The second output is going to be originally the benchmark minimum, and also the cow's name accordingly. And then you're going to update the benchmark, right? Case 2 is you had to update the second minimum, and here we are, right? Out is less than second output, and also out is greater than minimum output, and so on and so forth. You update the second output going to be out, and also cow got the cow. And then there are 2 tie situations for the benchmark for on the second to the minimum. Whichever it is, change the name to tie. Looking good. All right. Now get out of this for loop. Think about, is there any case that potentially we didn't capture here? Think about situations. All the output, let's say all 1. So eventually, do you think we get a chance to update our second cow? You know, without doing anything else, supposedly the answer here is, what is the file name again? Not last. We're gonna output what? Second cow, right? Right? Without doing anything else. But there's a situation is we don't have a chance to update the second cow. For example, like this. Why? So if you look at that, the first number you're gonna update the benchmark because the one's less than the original large number. And then later on, you got to keep checking the case 3. You got to keep checking on that because it keeps saying the 1 flowing in. And actually, we have no chance to update the second output or second cow. So if you print it out, they're going to print out it now, right? So we have to capture that situation is if second cow doesn't have a chance to be updated, which is due now. What does that mean? Well, it can be tie. And with that, you can go ahead and print it out. All right. So let's go through the code before I answer the question. So this is a question you need to think about to maintain a pair and also constant time to find a pair, which that's why we're using harsh map. And also there's a corner case is if there's any cow that does not show up in the log session, then the output going to be 0. That's why we put every cow into a harsh map and with initialization as 0. So just in case there's, the cow doesn't show up. And then for the end log sessions, we get the cow get output when maintain these are harsh maps, right? That's before we close the input. And then we rank we try to find the second to the least output by linear time transversal. And in order to do that, we got to maintain a rank board. Who is the minimum? Who is the second to the minimum? And what's her name? So that's that initialization as accordingly. And then this for loop is for transversal each entry in the hash map. So we can get a cow, we can get a stat. So people, this is different than hash stat because a hash stat implement iteratable. So for hash stat, you can use a for each to convert it, but not for hash map. I think I talked about why it designed as such from design perspective, right? From the sessions. So be careful, all right? Making sure syntax is all right. And we're gonna have 4 cases. Update the minimum, update the second, find the type with the minimum, and find the type with the second to the minimum. That's all about. And there's a corner case here, just in case we didn't have any chance to update the second minimum. Well, that's still gonna be tie, because the question already said, if everybody output with the same, then this still gonna be the tie. And then print it out. I have a question. Could you explain line 18? The line 18, that's how you update hash map by using put. The put is the syntax so that you can update the key value pair. The key gonna be the cow. So this one is new value. So this is the original value, right? And then this is new output from this given log session. That's why you want to get the sum and update this pair. And the line 29, this is a for each loop. So for each loop is for the object or class implement iteratable. Iteratable. Iterable. So that's why you can use it for each. And this is for each by creating a view of all the pairs behind the hash map, because in the hash map is literally the pair of key and a value. Now we want to convert it. And hash map, the map, does not implement the iteratable. That's why you cannot just put something, go ahead and for, and just go ahead and putting a hash map output. It really doesn't work. It doesn't work. The reason explained. That's why you have to call the entry set. This entry set does implement iteratable. That's why you can traverse what's in the entry set, and you had to capture by map entry type entry. All right. So this is syntax for a hash map, making sure it's solid. Any other questions before we submit the code? Okay, let's submit the code and then let's wrap it up by using priority queue. I think that's all about, right? Let's just test it. If there's a bug, we're gonna debug. And then let's go to sessions here. All right, I was waiting for that. All right, so this is a typical bronze level question. You see the time distribution is rather flatline because input number does not actually have a scale up. But like I said, we take this question as a vehicle to understand why we need a hash map, and also understand if n is really big, you cannot really sort it out to find the second to the largest one. But for instead, traverse it to find the second to the smallest one for this question. All right. Now, I think that's that, right? No questions for now. The product queue for these questions is another way to resolve the questions, not necessarily it's for the best time. Think about for this question, for the product queue, I don't think logic-wise it makes much differences, but in terms of your implementation, you got to be a little careful. That is, first of all, you're going to have a mean hip. The mean hip of product Q is the top number, always smallest one, and this is exactly what we want. So when you update all the pairs to the product queue, to harsh map, you can find and update it. But for product queue, it's going to be something different. Let me copy the this example. Let's show that, right? Hopefully, it's silver people, and you can practice by silver by product queue for these questions. Let's say you have a main hip, all right? Now for this main hip, let me try to simplify that. I don't like the word. I like character. So B, E. We have a, we don't. Okay, so first of all, you put E1 into your product queue. Product queue definitely going to implement. You definitely want to making you're creating a record to record the pair of the two numbers so they can reassert it in the product compare based on P or based on the value, to be honest, right? And which is a B1. And next one is going to be M3, M13. Definitely B1 stays on top because the one smallest one, right? And then what? And then I3, okay? So I3, and then E4, right? You see that if there's no duplication for the same key, it's just okay. But the challenge is what, folks? Anyone can figure out what is challenge? Hold on. I don't see that. Until you got 8 again. Ironically, why don't we have a duplicate for this question? B-M-I-E-H-G-E. That's hilarious, but that's okay. And then an A10. And then B6. There you go. The thing for this question is this, folks, is that you see that. Now, you have to update B6. Now, I mean, we are lucky. The top element is B1. What if you do not update B6? Let's update the I. Let's say I1, I2, for example. Now, we know that for product Q, you do not have a way to get to the number except the top number, right? So that's a challenge for such operation, which mostly is a little basic goal level, but I think it's still serve for silver people to dig a little bit. One way is called lazy deletion or detection, whichever way you want to use. So originally you have I2, you have to update this one as I5, right? But since you cannot really get to I3, you can only put I5. Let's say you already have a data structure already tells you what was the total output before you want to update the I, which is 3. So you want to input I5. So which means this I3 expires, right? How do we know that's expired? Then you can have some other data structure, for example, for step. So this set is, to be deleted, which is step. You put I3. So if this I3 pops up at the top element, you have to check from this to be deleted. If this I3 is indeed in to be deleted, you go ahead and delete it. This is called a latent detection. Actually, the better word is detection. Lazy detection. That is, well, go ahead and I want to pop the new element I5 in it. as to this I3, well, you know what, I don't care until this I3 really stays on top. For example, when you pop for the first time, you want to check on B1, is that within your to be deleted? If not, B1's gone, right? And then the next element is going to be what? I3, right? Main tip. We are maintaining the main tip based on the value here, based on the output. And then for the I3, you have to check whether or not I3 is valid or not valid. Not valid means to be deleted. So I3 is happen to be deleted. So this one, just go ahead and delete it. So which is not supposed to be in it. And then you're going to continue to pop the next smallest one, which is E4. And again, you're going to check against to be deleted. So see if I understand what I'm talking here. The algorithm is super easy by using priority queue. You basically want to pop the minimum one. So the elements sitting on top are going to be second to the minimum. That's going to be your answer. So you want to making sure while you're trying to maintain this priority queue, you're going to have to maintain the log, maintain the pair. But for some pair, you don't see it. So that's why you have to maintain to be deleted. Once that old pair, expired pair show up, go ahead and delete it. So that's the priority queue approach. Lazy detection. All right. So this is just for server people. Actually, if today we have Go levels, actually it's better for Go level as well. Anyway, that will be today's session. Hopefully people enjoy. Like I said, I hold the session. The point is not about you just spend 30, 45 minutes with me. I just want to use that to remind you to spend more time offline to prepare for your December USACO. All right, folks? Any other questions? All right. With that being said, I have a question from Inching. Can I see the code again? Yes, definitely. So this is code where, Michelle, how about I send to you? All right. Okay. With that being said, that's going to be our session, and I'll see you guys next week. Bye-bye, folks. Take care.